The function grab inside the back contract is used to kickstart liquidation. What it will do is confiscate a collateral that the user locked. This function grab can only be called by an authorized account. The authorized account, in this case, this is a contract called DOG. The DOG contract is a liquidation engine that will kickstart the liquidation for a bad debt. To kickstart a liquidation, anyone will be able to call a function called bark. And inside here, you can see over here that it calls the function vat.grab. In this video, we'll rewrite the function grab. So I'll copy this. And then inside our back contract, we rename this as CDP engine. I'll paste the code. So I'll paste the code maybe over here. And then run a forge format to format the code. Okay, and then here we have the function grab. Let's rewrite this. So first we have some parameters, and I'll explain what these parameters mean. The function grab will liquidate a CDP. The parameters mean that it will modify the CDP of user U, give the gem to user V, and then create SYN for user W. Here SYN, we renamed it as backdet. And then we also have two other parameters, dink and dart. Dink will be the change in collateral, the amount of collateral to take from user U. And dart will be the change in debt. From the amount of debt that they borrowed, this much amount, dart amount, will be deducted. And then lastly, I will be the identifier for the collateral type. Okay, so let's rename the inputs. We'll name the input I to call type, and then U will rename it as CDP, and then B will be the address that's going to receive the gem. So let's rename this to gem destination. And then W will be the destination of the unbacked debt. Let's rename this as debt destination. And then dink will be the change in collateral, delta call, and dart will be the change in debt, delta debt. And again, this function can only be called by an authorized account. Okay, moving on. It first gets the yearn and IOK. Let's rename these. Yearn will be the CDP position, so I'll rename it as position. And for yearns, I'll rename this as positions. I will be call type, and U will be the address that identifies the CDP. Okay, next we have IOK. We rename this as collateral. Then here I'll rename it as call, and here I'll rename it as collaterals. I will be call type again. Okay, and moving on. First, it updates the structs for yearn and IOK. Yearn will be position, so I'm gonna rename all yearn to POS, POS, POS. Then I'll do the same for IOK. ILK is call. Okay, and ink will be the amount of collateral that was locked. Let's rename this as, we rename this as collateral. Okay, and then POS position dot art. Art will be debt, so debt. And then call.art with a capital A. This will be debt, amount of debt that was borrowed against this type of collateral. So what it looks like it's doing is it's adding to the current amount of collateral for a position. The amount to be added will be dink. Now notice here, dink is int 256, and also delta debt, dart is int 256. Back inside the MakerDao's DSS DOG contract, you'll see that the way that the function grab is called is by passing in a negative number, minus dink. Since the amount of collateral will be deducted from the CDP, here we have a minus. And when we deduct this collateral, it's also going to deduct the debt. So here we have minus dart. So back inside our contract, when this function is called, this delta call and delta debt both will be negative. However, the position collateral is a uint256. So to add the uint256 with int256, you'll need to call an internal library that handles this. This is all handled by the function math.add. Math.add, and then math.add. Okay, so let's see what's going on here. It's gonna add to the current amount of collateral. The amount to add is dink. Dink, we renamed it as delta call. Since delta call is going to be negative, the result will be that the amount of collateral will be deducted from this CDP position. And the same goes for that. Dart will be a negative number, So the result will be that det will be deducted from this CDP. Okay, and then let's rename Dart as delta det. And then I'll do the same over here, delta det. Okay, moving on. Next, it creates a variable called dtab. What it's doing is it's multiplying IOK rate with Dart. IOK, we renamed it as collateral. And rate, we renamed it as rate accumulator. Dart will be delta det. When we multiply the rate accumulator by the delta det, what we're going to get is the amount of coin, the delta coin. Okay, and then moving on. Next, it updates the gem for call type for B. B will be gem destination. Okay, and then it's calling an internal function called sub. This will be math.sub. And the reason why we're calling math.sub over here is because the amount that is stored here, gem of call type at gem destination, this will be a uint256, and then to uint256 we're adding int256. And again, int256 will be a negative number here. To handle adding uint256 with int256, we're gonna let the library called math handle this. Since delta call is negative, when we subtract delta call, effectively it's gonna add delta call to gem destination. Okay, let's also rename this internal function math.sub, and then the same over here, math.sub. Okay, next, updates the state variable sim at the address w. We renamed sin as on backed debts, and w will be det destination, det DST. Okay, and then dtab will be delta coin. Okay, the last line of code is to update the state variable called vice. Vice, we renamed it as backed det, the total unbacked debt, unbacked debt. And then dtab, we renamed it as delta coin. Okay, that completes the function grab. Let's try compiling this contract. Inside my terminal, I'll type forge build. Okay, so I made some mistakes, so let's go back. First, I need to call math.mul, and total unbacked debt, I renamed it as system unbacked debt. Okay, let's try compiling again. And our contract compiles.